The Great Pyramid of Giza is a 4,500-year-old celestial clue. Ancient monuments across the globe hold a secret, a lost science of alignment that connects them directly to the stars. By the end of this, you will see the ancient world not as a collection of ruins, but as a sophisticated cosmic blueprint. We will uncover why a temple in Cambodia perfectly captures the spring equinox sunrise, and what a stone circle in the Egyptian desert reveals about a calendar older than the pyramids. How much of our history is written in a language of stone and sky, we have only just begun to understand to truly read these ancient stone messages. We need a new kind of translator, one fluent in both earth and sky. This is the precise role of archaeoastronomy, a field dedicated to uncovering how ancient cultures perceived and used the heavens. It is not merely stargazing, but a rigorous investigation that blends the hard data of astronomy with the cultural context of archaeology and anthropology. Researchers in this field employ sophisticated tools, from theodolites for precise ground measurements to complex software that can roll back the cosmic clock. They recreate the night sky as it looked thousands of years ago, plotting the precise rising and setting points of stars that have since drifted from their ancient positions. This process is what separates random chance from intentional design. A doorway facing east might be a coincidence, but if that doorway aligns with the sunrise on a specific day that held profound meaning for that culture, and this pattern is repeated across multiple sites, then we are likely witnessing a celestial blueprint. This scientific lens transforms enigmatic ruins from mere piles of stone into sophisticated instruments, each one a frozen moment in humanity's long conversation with the cosmos. And no structure embodies this conversation more profoundly than the Great Pyramid of Giza. The Great Pyramid itself is a masterclass in this solar logic. Its sides are aligned with the cardinal directions with an accuracy of less than 1/20th of a degree, a feat that seems to defy the building capabilities of a 4,500-year-old civilization. This was far more than an architectural flex. It was a direct alignment with the fundamental order of the cosmos as they perceived it. The sun's daily journey from east to west and its yearly trek between the solstices provided a stable, predictable framework for existence. For societies dependent on agriculture, knowing precisely when to plant and when to harvest was a matter of survival. The solstices and equinoxes became the cornerstones of their calendar, and they built these astronomical events into their most permanent structures. In Ireland, the massive 5,000-year-old tomb at Newgrange is a perfect example. Its entire design centers on a single, fleeting moment each year. At dawn on the winter solstice, the darkest day of the year, a narrow beam of sunlight pierces a specially constructed roof box above the entrance. This shaft of light travels down a long, narrow passageway, finally flooding the inner burial chamber with golden light for a period of just 17 minutes. This was not a random occurrence. It was a meticulously engineered spectacle, a dramatic assertion that even in the depths of winter, the light and life would return. Half a world away, the ancient Egyptians expressed a similar solar devotion on a colossal scale. The Temple of Karnak is a sprawling complex of sanctuaries and halls, but its main axis is precisely oriented. On the summer solstice, the sun would rise directly along this line, its rays penetrating deep into the temple's heart to illuminate the inner sanctuary of the sun god Amun-Ra. In that brilliant moment, stone and sky merged, demonstrating the pharaoh's divine connection and celebrating the sun's peak power. These structures were not passive observatories. they were active participants in a celestial drama, embedding the unerring rhythm of the solar year into the very landscape. And just as the sun commanded their days, its silent partner, the moon, governed the mysteries of the night. But the moon presented a very different kind of clock. Its cycle is far more complex than the sun's steady annual rhythm, offering a shorter, more intricate calendar perfect for scheduling sacred rituals and community ceremonies. Unlike the sun, which reliably marks the same horizon points year after year, the moon's path is a long, slow dance. Its orbit is tilted relative to Earth's, so over a period of 18.6 years, the points on the horizon where it rises and sets slowly sweep north and south. The absolute limits of this motion are called the major standstills, the most northerly and southerly positions the moon will ever reach. Pinpointing this cycle required patience spanning generations, a testament to a deep and sustained celestial tradition. The Mnajdra temple complex on the Mediterranean island of Malta is a breathtaking example of this lunar precision. Here, massive stone temples older than the pyramids were engineered with stunning foresight. Specific doorways and corridors frame the rising sun during the equinoxes, but they also perfectly frame the rising moon at its extreme southern major standstill. This was no lucky guess. It was the result of centuries of meticulous observation, likely managed by a dedicated priestly class whose sole purpose was to read and record the sky. This knowledge of lunar extremes was not confined to the Mediterranean. On the Salisbury Plain in England, the architects of Stonehenge also wove the moon's long rhythm into their grand design. The so-called station stones and the famous heel stone are thought to align not only with the solstice sun, but also with the moon at its major standstills. This created a master calendar, a cosmic engine that integrated the cycles of both the day and the night. This lunar knowledge provided a dynamic, multi-generational clock, weaving a far more complex temporal tapestry into the landscape than a purely solar calendar could ever achieve. Yet the ancient sky watchers looked even further beyond the comforting rhythms of our solar system to the fixed and distant stars. The stars offered a grander, more permanent map in the sky. Unlike the sun and moon, which cycled predictably overhead, the so-called fixed stars provided a seemingly eternal backdrop for myth and navigation. Yet even this starry canvas was not entirely still. A slow, imperceptible wobble in Earth's rotation, known as the precession of the equinoxes, causes our planet's axis to trace a circle in the heavens over a vast 26,000-year cycle. This means the entire celestial landscape shifts over the centuries. The star we know as Polaris is our current North Star, but it has not always held that position, and it will not hold it forever. This profound astronomical insight appears to be encoded in the very stones of the Great Pyramid. While its sides are famously aligned to the four cardinal directions, its internal shafts tell a more specific story. The pyramid's southern air shafts are theorized to have been precisely aimed at the star Sirius, which the ancient Egyptians linked to the goddess Isis. More strikingly, the northern shaft points directly toward the star Thuban. Around 2,500 years before the Common Era, Thuban was the pole star, the pivot around which the entire night sky appeared to turn. The pyramid's builders did not just create a timeless geometric shape, they engineered a celestial snapshot, permanently anchoring their monument to the precise configuration of the heavens at the moment of its creation. This represents a breathtaking long-term vision, an acknowledgement that the sky itself was in motion and that their most sacred architecture needed to be fixed to a specific cosmic moment. These stellar alignments often served as bridges, literal pathways for the soul to travel to the realm of the gods after death. But how did these ancient architects without modern instruments achieve such pinpoint celestial accuracy? Their tools were deceptively simple, yet their application was genius. The true genius of these ancient architects lies not in the tools they lacked, but in the profound knowledge they possessed. To achieve alignments accurate to a fraction of a degree, they relied on deceptively simple instruments and a deep understanding of geometry. In ancient Egypt, the key was the merkit, a device made from a palm rib with a vertical slit and a hanging plumb bob. An observer would sight a specific star through the slit, using the plumb line's vertical drop as a celestial reference to establish a true meridian line across the sky. This single observation could anchor an entire construction project to the cosmos. On the ground, the technology was even more rudimentary yet equally effective. Long, straight lines were established using nothing more than a series of sighting poles, while ropes, carefully measured and kept taut, translated these celestial directions into terrestrial foundations. To ensure these foundations were perfectly level, builders used water-filled trenches, exploiting water's natural tendency to find a flat plane. One of the most elegant methods for finding true north involved no tools at all, just patient observation of a single star. This technique, sometimes called the Indian circle method, required an observer to mark the spot on the horizon where a bright star first rose, and then the point where it later set. By bisecting the arc between these 2 points, they could pinpoint the celestial north with astonishing precision. Modern experiments have proven that a skilled team using these basic methods could replicate the alignments we see in monuments like the Great Pyramid. The so-called lost science was not magic. It was the powerful combination of applied geometry and generations of meticulous sky watching, a testament to human ingenuity that turned simple sticks and strings into a language for speaking with the heavens. This same meticulous logic was applied on a breathtaking scale, not just to solitary temples, but to entire cities designed as grand metaphors of the cosmos. This precise 15.5-degree orientation was a deliberate choice, a signature written in stone and aligned with the stars. The entire city grid was rotated to face the setting point of the Pleiades star cluster on a day of immense solar significance when the sun reached its zenith directly overhead. For the people of Teotihuacan, this was a moment of perfect balance, a time when celestial and terrestrial power converged. The Pleiades, a compact and brilliant grouping of stars, held deep cultural importance across Mesoamerica, often associated with the agricultural cycle and the rain. By aligning their entire urban plan to this specific celestial event, the city's planners were weaving the fabric of their daily lives into the tapestry of the cosmos. This was not just an alignment for a single temple, but a blueprint for an entire metropolis. The Great Pyramid of the Sun and the Pyramid of the Moon are not placed randomly along the Street of the Dead. Their positions and relative sizes create a deliberate spatial rhythm, one that scholars suggest may mirror the perceived distances and relationships between celestial bodies. Walking from one pyramid to another was not merely a physical journey, it was a symbolic passage through a sacred landscape that mirrored the heavens. The city itself was a working model of the universe, a microcosm where every citizen lived and moved within a divinely ordered space. This grand vision of a city as a cosmic map was a powerful idea that echoed across the ancient world. Far to the east, the sandstone towers of Angkor Wat rise from the Cambodian jungle as a perfect stone model of the universe. This colossal temple complex is not merely a collection of buildings, it is a three-dimensional map of Hindu and Buddhist cosmology. The entire site is enclosed by a massive moat representing the primordial ocean, while the central quincunx of towers symbolizes the 5 peaks of Mount Meru, the mythical axis of the world and the dwelling place of the gods. Every element of its design, from the concentric galleries to the precise placement of its libraries, reinforces this celestial geography, but one of its most defining features is its orientation. Unlike most Hindu temples which face east, Angkor Wat opens to the west, a direction often associated with the god Vishnu and the realm of the ancestors. This was a deliberate and profoundly significant choice. It positions the entire structure for one of the most breathtaking alignments in the ancient world. On the morning of the spring equinox, an observer standing at the western gateway witnesses the sun rise in perfect alignment directly over the central tower. This annual event is no accident. It is a meticulously engineered moment where the sun's light symbolically ignites the spiritual heart of the temple, affirming the connection between the celestial order and the earthly realm. The cosmic symbolism is carved into the very walls. The extensive bas-relief galleries, which stretch for hundreds of meters, do more than tell mythological stories. They chart celestial journeys and cosmic battles, integrating narrative with astronomy in a continuous stone tapestry. The recent use of LIDAR technology, which can see through the dense forest canopy, has revealed that this celestial logic did not stop at the temple walls. The data shows that the entire city of Angkor, one of the largest pre-industrial cities in the world, was laid out on a vast and precisely oriented grid. The main temples and roadways were aligned to the cardinal directions with an accuracy that mirrors the temple's own strict orientation. This reveals a holistic world view where astronomy was not a separate discipline, but the foundational principle for all urban planning. The sacred space of the temple was simply the concentrated center of a much larger sacred landscape, a city designed from the ground up as a reflection of the cosmos. This unified vision of heaven and earth finds a powerful and surprisingly different echo in the arid landscapes of the Middle East. Long before the first stone was laid at Giza, a different kind of calendar was being etched into the desert floor. In the vast, arid basin of Egypt's Nubian desert lies Nabta Playa, a collection of stones that may be the world's oldest known astronomical observatory. Dating back to around 4,500 years before the Common Era, this site predates Stonehenge and the Great Pyramid by millennia. It is not a city or a fortress, but a stark, deliberate arrangement of megaliths erected by nomadic cattle herders. These people did not build for eternity, they built for necessity, creating a ceremonial center that came to life only during the brief, precious rainy season. Their legacy is a stone circle and a series of aligned slabs that speak of a sophisticated understanding of the sky. The primary stones are aligned to the rising sun of the summer solstice, while others mark the cardinal directions with surprising accuracy. One especially significant slab, lying flat on the desert floor, is believed to have been aligned with the heliacal rising of the star Sirius, its first appearance in the dawn sky after a long absence. For these desert people, this celestial event was not an abstract wonder. It was a critical signal, a herald of the coming monsoon rains that would transform the desert into life-sustaining pasture for their herds. This stone calendar was their way of predicting the rhythm of the seasons, turning the unpredictable heavens into a reliable guide for survival. Nabta Playa fundamentally rewrites the story of monumental astronomy. It demonstrates that the drive to map the heavens did not begin with the grand empires and their stone cities. Instead, it emerged from the practical needs of nomadic societies, from a universal human impulse to read the sky in order to navigate the earth. This ancient precedent suggests the roots of this science are far deeper and more widespread than we ever imagined, pointing toward a shared, global knowledge that flourished in isolation long before history was written. This shared celestial language carved in stone across the globe presents us with an unresolved and profound question. How is it that cultures separated by vast oceans and thousands of years all arrived at the same sophisticated principles of alignment? The academic world is divided into two compelling camps. On one side is the theory of independent invention, known as polygenesis. This view suggests that when any intelligent human society looks up at the same sun, moon, and stars, they will naturally begin to track the same cycles. The solstices and equinoxes are not hidden secrets. They are obvious events marked by the sun's extreme positions on the horizon, observable to anyone who pays attention over a few annual cycles. Building a monument to honor that cycle becomes a logical, even inevitable, next step. In this light, the similarities between a pyramid in Egypt and a temple in Cambodia are not evidence of contact, but a testament to the universal human mind confronting the same cosmic patterns. Yet the other side, the diffusionists, point to something deeper and more specific. They argue that the parallels go far beyond simple solstice markers. How do we explain the precise appearance of advanced mathematical concepts like the ratio of pi, the golden ratio, or the principles of the Pythagorean theorem in the construction of monuments that were built millennia apart? These are not simple observations of the horizon. They are abstract constants, sophisticated fruits of a developed geometry. For diffusionists, this points to a monogenesis, a single, now vanished source of this advanced knowledge. They propose a lost civilization, perhaps a maritime culture that navigated the globe in prehistory, spreading a core system of astronomical and geometric science. This could have been a real, seafaring society lost to rising sea levels at the end of the last ice age, a historical reality that later inspired the myth of Atlantis. The debate forces us to look past the stones themselves and into the minds of the builders. Were they isolated geniuses, or were they the inheritors of a forgotten worldwide tradition? This intellectual elite did not simply watch the stars, they recorded their motions with obsessive precision. In the shadow of Mesopotamian ziggurats, priest-astronomers produced thousands of clay tablets filled with cuneiform script. These were not mystical prophecies but meticulous astronomical diaries. They logged the movements of planets, the timing of lunar eclipses, and the positions of stars, creating a vast data set that spanned centuries. This long-term observation was the key to their power. By recognizing repeating patterns, they could predict celestial events with remarkable accuracy. An eclipse was not a terrifying surprise, but a predictable occurrence that could be managed and interpreted. This ability to foresee the gods' plans made them indispensable advisors to kings. The timing of a military campaign, the coronation of a new ruler, or the signing of a treaty all hinged on a favorable celestial reading. Their knowledge was a direct line to the divine, and it cemented their position at the very top of the social hierarchy. The great monuments they oversaw were the ultimate expression of this authority. A pyramid aligned to the pole star was not just a tomb, it was a permanent declaration that the ruler and his priests could command the very axis of the heavens. This profound link between celestial observation and earthly power reveals a sophisticated scientific tradition operating under the guise of religion. We are only now beginning to decipher the full extent of their astronomical legacy, a legacy written not in sand but in stone and clay for the ages. This celestial logic was carved not just in alignment but in proportion. The very shapes of these monuments encode a hidden mathematical language, one that speaks of pi and the golden ratio. Take the Great Pyramid. Its base perimeter divided by twice its original height yields a figure startlingly close to 2 pi. This is not a random number. It is the fundamental constant that defines a circle, the ratio of a circle's circumference to its diameter. To find this relationship embodied in a four-sided pyramid suggests the builders possessed a deep, perhaps symbolic, understanding of spherical geometry. They were not merely stacking stones, they were building a model of cosmic order. A similar principle guided the architects of the Parthenon in Greece. Its majestic facade is a masterpiece of the golden ratio, a proportion where a line is divided so that the whole length is to the longer segment as the longer segment is to the shorter. This ratio, approximately 1.618, appears throughout nature, from the spiral of a nautilus shell to the arrangement of seeds in a sunflower. For the ancient Greeks, it represented a divine harmony, the mathematical signature of beauty itself. By weaving this ratio into every dimension of the temple, they were attempting to create a structure that was not just beautiful but perfect, an earthly echo of a universal principle. Why go to such lengths? Some scholars point to the concept of sacred geometry, the belief that certain shapes and ratios possess spiritual power and reflect the fundamental building blocks of creation. Encoding pi into a pyramid or phi into a temple was a way to harmonize human creation with the perceived mathematical mind of the cosmos. The pyramid, therefore, was more than a tomb aligned with the stars. Its very form was a mathematical expression of celestial principles, a physical bridge between the measurable world and the intangible realm of the divine. This fusion of astronomy, mathematics, and spirituality represents the absolute pinnacle of this lost science, but such profound understanding could not last forever. What happened to this unified vision of the universe? This grand synthesis of sky, stone, and spirit could not endure forever. The decline of this unified science was a slow unraveling, a great forgetting driven by profound changes in how humanity saw itself and its place in the universe. It began with the collapse of the great Bronze Age networks, when empires like the Mycenaeans or the sprawling cities of the Indus Valley fractured, their intricate social structures shattered with them. The specialized priestly classes, the guardians of generations of astronomical data, were dispersed. The long, unbroken chains of observation and oral tradition were severed, and with them went the deep, cumulative knowledge required to build another Newgrange or to track the moon's 18-year cycle. The foundation of the science itself crumbled. Then came a spiritual revolution. The rise of powerful monotheistic faiths introduced a divine presence that was often transcendent, separate from the natural world. The gods were no longer in the sun, the moon, or the stars. Celestial bodies were demoted from living deities to mere creations, beautiful but ultimately impersonal lights in the sky. Why build a temple to capture the soul of a star when that star was no longer considered a divine being? The motivation for such precise alignments faded, replaced by new forms of worship that turned inward, away from the horizon. Practicality also played its part. Why dedicate a lifetime to building a stone calendar when a portable mechanical clock could tell the time more accurately and without any reference to the sky? The development of precise timekeeping devices liberated society from its direct dependence on celestial cycles. A clock worked in any weather, day or night. It was a tool of commerce and industry, not ritual. The great monuments became functionally obsolete, their original purpose as giant astronomical instruments no longer understood or needed. The final blow was intellectual fragmentation. The scientific revolution of the 16th and 17th centuries, for all its brilliance, championed a new way of knowing. It insisted on separating disciplines. Astronomy became the study of physical bodies in space, a mathematical science. Architecture became an engineering and aesthetic pursuit. Spirituality was relegated to the realm of faith and theology. The holistic vision that saw a pyramid as simultaneously an observatory, a mathematical model, and a spiritual gateway was fractured into disconnected specialties. The knowledge did not disappear in a single cataclysm. It was simply abandoned piece by piece, its integrated logic becoming irrelevant to a changing world. The stones were left behind, magnificent and mute, their original language no longer spoken. Yet today, armed with new tools and a renewed sense of wonder, we are slowly learning to read that language again. The silent stones finally found their voice again in the 19th century through a new breed of investigator who dared to merge the telescope with the trowel. Astronomer Sir Norman Lockyer, gazing at the same skies that had guided the ancients, turned his scientific eye toward the great monuments themselves. He was not content with mythological explanations for the orientation of Egyptian temples or the strange alignments at Stonehenge. He applied precise astronomical calculations, correcting for the slow precession of the equinoxes to reconstruct the skies of millennia past. His work suggested that the temple of Amun-Ra at Karnak was aligned to the rising of the midwinter sun, a radical idea that challenged the purely artistic interpretation of ancient ruins. Decades later, in the 1960s, an astrophysicist named Gerald Hawkins took this approach a dramatic step further. He fed the positions of the stones at Stonehenge into an early IBM computer, searching for patterns. The results were explosive. Hawkins proposed that the famous stone circle was not just a ceremonial site, but a sophisticated Neolithic computer, capable of predicting lunar eclipses through a complex arrangement of its pillars and arches. His book, Stonehenge Decoded, ignited fierce public fascination and equally fierce academic backlash. Archaeologists accused him of oversimplifying a complex cultural site, of reducing a sacred landscape to a mere celestial mechanism. Yet the controversy itself was vital, forcing a long overdue conversation between the hard sciences and the humanities. Around the same time, a quiet but immensely dedicated Scottish engineer named Alexander Thom was conducting his own monumental survey. He traveled across Britain and France, meticulously measuring hundreds of megalithic sites with the precision of his profession. What he found was staggering. He identified recurring geometrical shapes in the stone circles, from flattened circles to precise ellipses, all built with a shared mathematical understanding. More astonishingly, he proposed that the builders had used a standard unit of measurement, a megalithic yard of approximately 2.72 feet, which appeared to have been used from Scotland to Brittany. This implied a level of communication and shared technical knowledge across a vast territory that historians had never suspected. These pioneers, Lockyer, Hawkins, and Thom, were often dismissed as outsiders and mavericks. They faced an establishment deeply skeptical of what it saw as astronomical speculation, a fear of overshadowing the cultural and human story of these sites. But their collective legacy is undeniable. They were the first to systematically ask a question we now take for granted. What if the ancients were not primitive mystics, but keen, systematic scientists of their own time? Their stubborn curiosity, often met with ridicule, laid the essential groundwork for the respected interdisciplinary field we know today as Archaeoastronomy. They gave us the first lexicon to begin translating the language of stone and sky, a translation that continues with ever more powerful tools at our disposal. Laser pulses fired from aircraft are now stripping away the jungle, revealing a hidden world. This technology, known as light detection and ranging, or LIDAR, works by sending millions of laser beams downward from a plane or drone. These beams penetrate the dense leaves and branches of a forest canopy, bouncing off the solid ground below. By measuring the time it takes for each pulse to return, computers can construct a breathtakingly detailed three-dimensional map of the actual Earth's surface, a landscape that has been invisible for centuries. The impact on sites like Angkor Wat has been nothing short of revolutionary. For generations, we saw the Great Temple as a magnificent island in a green sea, a solitary masterpiece. LIDAR has utterly shattered that illusion. The maps now show that Angkor was not just a temple complex. It was the beating heart of a vast, sprawling metropolis, one of the largest pre-industrial cities on Earth. The technology revealed an immense urban grid extending for hundreds of square miles, crisscrossed by precisely aligned roadways and sophisticated canals. This was not a haphazard collection of villages. It was a meticulously planned celestial city, the same strict cardinal orientation found in the Temple of Angkor Wat governs the entire urban plan. The main roads, the canals, and the boundaries of smaller temples all align to the same cosmic directions. This proves the astronomical alignment was not just for priests in a sacred space. It was the foundational blueprint for every aspect of daily life, from travel and trade to water and agriculture. The entire landscape was engineered as a single, unified instrument, harmonizing human existence with the cosmos. A similar story is unfolding deep in the Guatemalan jungle, where LIDAR is rewriting the history of the Maya. The technology has uncovered immense networks of raised causeways connecting cities we once believed were independent. It has revealed vast agricultural fields and complex water management systems on a scale no one thought possible. Most strikingly, these newly discovered urban centers are also laid out along astronomically significant axes. What we once called isolated ceremonial centers are now understood as interconnected nodes in a vast, consciously designed network. This new evidence forces a complete reassessment of ancient capabilities. We are no longer looking at cultures that simply built temples to the stars. We are witnessing cultures that built entire worlds to mirror the heavens, engineering the very land itself into a grand, terrestrial replica of the celestial order. The true scale of their vision was literally hidden in plain sight beneath a canopy of trees. Even the most compelling celestial alignments face a rigorous test of skepticism. For every site that seems to perfectly frame a solstice sun, critics point to the basic mathematics of chance. A sprawling complex like Stonehenge has dozens of stones, while the night sky holds thousands of visible stars. If you draw enough lines between enough points, some are bound to point to something significant purely by accident. This is the argument from coincidence, and it forces researchers to move beyond isolated examples. The true test is whether a pattern repeats across multiple sites within a culture, forming a consistent system rather than a lucky guess. An even more subtle challenge is confirmation bias, the natural human tendency to see what we want to see. An investigator convinced that a culture tracked the star Sirius might focus only on the one doorway that aligns with it, while ignoring three others that point to empty sky. We are all prone to cherry-picking evidence that fits a beautiful theory, overlooking the messy data that contradicts it. This is why the methodology is so crucial. It is not enough to find a single alignment. Researchers must survey an entire site, record every orientation, and then ask if the significant ones correlate with celestial events that held documented meaning for that specific culture. The evidence must be more than just geometrical, it has to be cultural as well. Then there is the complication of time itself, the celestial noise introduced by the precession of the equinoxes. A temple doorway aligned to the rising of the star Aldebaran 4,000 years ago would not frame that same star today. The sky has slowly drifted, meaning our modern measurements are just a snapshot of a moving target. To confirm an ancient alignment, scientists must use software to rewind the sky. calculating precisely where stars and constellations appeared on the horizon millennia in the past. This transforms a subjective hunch into a testable astronomical hypothesis. The most credible claims are those supported by a convergence of evidence. Does the alignment match the prehistoric sky? Does it repeat across multiple structures? And most importantly, does archaeology provide corroborating clues, like artwork depicting that specific star or texts describing a festival on that exact date? This multidisciplinary approach is what separates a compelling pattern from a simple coincidence. This healthy skepticism is not a dismissal of the ancient science, but the very process that gives it credibility. By confronting these challenges head-on, researchers are building a stronger, more convincing case for how deeply our ancestors truly understood the cosmos. So the stones were more than just celestial clocks for planting crops. Their true power may have lain in their ability to unite thousands of people under a single, sky-born vision. Coordinating the labor to build a pyramid required a massive, organized society, a civilization pulling together for a goal that spanned generations. This collective effort forged a powerful sense of shared identity and purpose. But for the ruling elite who directed this work, the celestial alignment served a second, crucial function: cosmic legitimization. By designing a monument that captured the solstice sun or the pole star, they were making a profound claim. Their authority was not merely a human invention. It was divinely ordained, written into the very fabric of the cosmos. The pharaoh did not just rule because he said so. He ruled because the sun itself rose along the axis of his temple, flooding the inner sanctum with light on the most sacred day of the year. In that brilliant moment, stone and sky merged to demonstrate his divine connection. The monument became a permanent, immutable symbol of this social contract. Every citizen, looking up at the immense, perfectly aligned structure, received a constant reminder. The cosmic order that governed the heavens was the same order that justified the social hierarchy on Earth. Why obey the king? Because the stars themselves obeyed their own paths, and his rule was part of that same unchangeable law. This was a tool for building civilization itself. The lost science was not merely about tracking time. It was about creating a common ideology so powerful that people would dedicate their lives to its construction. The sheer scale and permanence of these projects make perfect sense when you see them not just as observatories, but as the foundational pillars of an entire social order, engineered in stone and aligned with eternity. This cosmic blueprint extended its reach to the very source of life itself, water. For ancient cultures, the celestial river of the Milky Way was not just a beautiful band of light. It was a direct counterpart to the terrestrial rivers that nourished their fields and quenched their thirst. They saw a single, flowing system where the waters above mirrored the waters below. In the sacred landscape of Abydos, Egypt, a mysterious and profoundly ancient structure known as the Osirian lies behind the Temple of Seti I. This massive granite-lined hall, often flooded by groundwater, was deliberately oriented. Its axis aligns with the rising of the constellation Orion, which the Egyptians linked to the god of death and rebirth, Osiris. But the celestial alignment does not exist in isolation. The structure is intrinsically connected to a subterranean water channel, a symbolic vein linking it to the life-giving Nile. In their mythology, the Nile was the earthly echo of the Milky Way. The annual inundation of the river, which deposited fertile silt across the land, was seen as a direct consequence of celestial events. By aligning a monument to both Orion and the underground waters, they were physically binding the cycles of death, rebirth, and fertility into a single, powerful statement. The heavens dictated the flow of water, and water dictated the rhythm of life on Earth. this same profound connection was engineered half a world away. Across the Maya world, the landscape is dotted with cenotes, vast natural sinkholes that expose hidden groundwater. These were not merely practical water sources. They were considered sacred portals to the underworld, the realm of the gods and ancestors. The Maya did not build their cities near cenotes by accident. They designed their entire urban plans around them, and those plans were often laid out to reflect specific celestial patterns. Certain city layouts are thought to mirror the shape of water-associated constellations, creating a giant map on the ground that corresponded to the map in the sky. A ceremony performed at a temple aligned with a specific star might be conducted directly above a cenote that represented that star's underworld counterpart. This was a complete, closed loop of meaning. The rain from the heavens filled the cenotes which sustained the people, whose rituals in the celestially aligned city ensured the rains would return. It was a perfect fusion of hydrology and astronomy, a single, coherent system that managed both practical survival and spiritual belief. The flow of stars across the night sky and the flow of water through the earth were two expressions of the same divine, life-sustaining current. The sky was a grand, starry storybook, and its most compelling characters were the animals that roamed the celestial plains. The same cluster of stars we identify as a great bear was seen by the ancient Greeks as a mighty wagon, while in Egypt it formed the foreleg of a celestial bull. These were not random labels, they were the central figures of cosmic myths, narratives that gave meaning to the shimmering patterns overhead. This animal symbolism was then brought down to earth, carved into the very first stones humanity ever raised to the sky. At Göbekli Tepe in Turkey, a temple complex so ancient it predates Stonehenge by 6,000 years, the evidence is staggering. Enormous T-shaped pillars stand in silent circles, each one a granite canvas for a menagerie of beasts. Foxes, cranes, scorpions, and vultures are rendered in exquisite detail, their forms emerging from the stone. But why were these specific animals chosen, and why here? The answer may be written in the stars. Some researchers have mapped the arrangement of these pillars and found a startling correlation. They propose that the layout of the enclosures corresponds to the stars of what we call the constellation Scorpius, which the builders of Göbekli Tepe might have seen as a great vulture in the sky. Even more remarkably, this configuration appears to snapshot a specific celestial event from around 11,500 years before the Common Era, a time when the first pillars were being erected. This means the world's oldest known temple complex was not just a place of ritual, it was a monumental, three-dimensional star chart, using animal avatars to permanently fix a moment in cosmic time. The very dawn of human architecture was already speaking the sophisticated language of celestial alignment, a language of stone and sky that we are only now beginning to decipher. The stones were not just meant to be seen, but to be heard. A new frontier in this lost science is revealing how ancient builders engineered their monuments for sound, creating a resonance that may have been as vital as any alignment to the sun. Deep underground on the island of Malta, within the 5,000-year-old hypogeum, lies the oracle chamber. This small, rock-cut room possesses an extraordinary acoustic property. A deep voice spoken into a specific niche does not merely echo. It is amplified and distorted, its vibrations felt through the very stone, creating an otherworldly effect that seems to emanate from everywhere at once. This was no accident of geology. The chamber was carved to achieve this precise sonic result, likely to give a disembodied, godlike power to the voice of a priest or shaman during sacred rites. Far across the Atlantic, a similar acoustic genius is on display. At the base of the great Mayan pyramid of Kukulkan at Chichen Itza, a single handclap produces a startlingly unnatural echo. Instead of a simple repetition, the sound that returns from the massive stone staircase is a pulsing, chirping trill, an uncanny imitation of the sacred Quetzal bird. The Quetzal, with its brilliant green plumage, was considered a divine messenger, a creature that bridged the earthly and heavenly realms. To have the very temple of a feathered serpent god literally call back with the voice of a sacred bird transforms an architectural marvel into a living, speaking entity. This was not a parlor trick. It was a deliberate fusion of auditory and celestial symbolism. Some researchers propose that these resonant frequencies were carefully calibrated to mimic the perceived music of the spheres, the harmonic hum ancient philosophers believed the planets made as they moved through the heavens. By engineering these sonic effects, the builders were harmonizing their sacred spaces with the entire cosmos, not just as a visual map, but as a vibrational one. The right frequency, sustained within a stone chamber, can alter brainwave patterns, potentially guiding participants into trance-like states conducive to ritual and vision. Imagine a ceremony timed to the solstice sunrise. As the first sliver of light pierced the temple doorway, illuminating the inner sanctum, the chamber would simultaneously be filled with a powerful, resonant drone. In that moment, the visual spectacle of celestial alignment and the overwhelming auditory experience would merge, dissolving the boundary between the individual and the universe. This was a cosmological design that engaged every sense, a holistic sacred science where sight, sound, and space were unified into a single, immersive reality. The monuments were not silent sentinels. They were instruments tuned not just to the positions of the stars, but to the very frequency of the divine. But what if the sky itself was not the only thing that moved? A more radical idea suggests the very ground beneath these ancient monuments has reoriented itself in a planetary drama known as true polar wander. This is not the slow drift of plate tectonics, where continents jostle like rafts on a pond. Instead, it is a hypothetical reorientation of Earth's entire outer shell, the crust and mantle, shifting together over the liquid outer core. Imagine the skin of an orange slipping around its juicy interior, moving the geographic north and south poles to new locations. Such an event would be catastrophic, recalibrating the entire planet. The latitude of every continent would change, and with it, the entire celestial stage would appear to tilt. Stars that once marked the pole would drift away, and the sun's path across the sky would be fundamentally altered. For the builders of a monument perfectly aligned to a star that was no longer at the pole, their celestial masterpiece would appear broken, its meaning lost to a world that had literally shifted beneath its feet. Proponents of this controversial theory point to specific anomalies, sites where the alignment seems just a few degrees off from any significant star in our current sky. They run complex models asking a simple but profound question. What if the poles were located somewhere else, say in Hudson Bay 10,000 years ago? When they plug this new pole position into their astronomical software, something remarkable can happen. Monuments that seem misaligned today suddenly snap into perfect focus, their sight lines pointing directly to significant stars in that recalibrated ancient sky. It is as if we have been trying to read a map with the wrong compass, and this hypothesis offers a corrected north. Of course, mainstream geology remains deeply skeptical. The evidence for any rapid, recent shift of the entire crust is thin, with most scientists believing true polar wander, if it occurs, happens over millions of years, not within the time frame of human civilization. The established view holds our planetary axis has been relatively stable, yet the value of this radical idea is not necessarily in its truth, but in the perspective it forces upon us. It challenges the comforting assumption that our planet is a fixed stage. it introduces a profound instability, reminding us that the Earth is a dynamic, living system. Perhaps the most important alignment is not between a stone and a star, but between our modern theories and the stubborn, anomalous data left behind by the ancients. These outliers in the data are not mere mistakes. They are clues, pushing us to consider possibilities we may have previously dismissed, forcing us to look at the entire celestial puzzle from a completely new and unsettling angle. The silent stones find their voice in living traditions that have never lost their connection to the sky. Across the vast Pacific Ocean, Polynesian navigators accomplished feats of exploration that seem almost superhuman. Without a single compass or sextant, they guided their double-hulled canoes across thousands of miles of open water from Tahiti to Hawaii. Their secret was a mental map of the heavens known as the star compass. They did not just know the names of a few bright stars. They had memorized the precise rising and setting points of hundreds of stars, using them as fixed celestial signposts on the horizon. As one star would rise too high to be useful, another would be appearing in the east, creating a rotating star path highway across the night. They also read the ocean itself, interpreting the patterns of swells, the flight paths of birds, and the color of the clouds. This was not an abstract science studied in isolation. It was a practical, embodied knowledge passed down through chants and apprenticeships, where the sky was a literal roadmap for survival and migration. It was a celestial logic in constant, dynamic use. On the other side of the world, the Hopi people of the American Southwest practice a different but equally profound form of sky watching. Their landscape is their observatory. They use the dramatic silhouette of the mesas on the horizon as a giant, natural calendar. By carefully observing the sun's daily shifting position along this skyline from a fixed point, their sun watchers can pinpoint the solstices, the equinoxes, and other critical dates. This is not done for curiosity. It directly governs their entire ceremonial cycle, telling them precisely when to plant corn, when to hold the sacred Kachina dances, and when to prepare for the winter months. The calendar is woven into their language, their stories, and their very identity. For them, the cosmos is a participant in daily life, not a distant spectacle. These living traditions are more than just cultural treasures. They provide a vital ethnographic analogy, a window into the ancient mindset. They show us that for the Polynesian navigators, the Hopi sun watchers, and likely for the builders of Göbekli Tepe and the Great Pyramid, astronomy was never a separate technical discipline. It was the very fabric of a holistic culture, inseparable from navigation, agriculture, governance, and spirituality. It was a way of being in the world where every sunrise and every star set carried meaning, guiding not just the hands that built the monuments, but the hearts that gave them purpose. This contemporary context does more than just explain the stones. It breathes the warmth of a living, breathing culture back into their cold, silent forms. This digital time machine has fundamentally changed the game. With programs like Stellarium, an archaeoastronomer can sit at a computer and command the sky to roll back thousands of years. They input the exact latitude and longitude of a remote stone circle, specify a date like 2800 BCE, and watch as the software reconstructs the night. It calculates everything from the slow precession that shifts the pole star over centuries to the tiny wobbles in the moon's orbit. A researcher can then take the measured orientation of a temple's central axis, draw a virtual line from it out to the horizon, and see what celestial body, if any, rose or set at that precise point. What was once an educated guess is now a testable, verifiable fact. We can see that a corridor in a Maltese temple did indeed frame the bright star Capella as it first appeared above the horizon 4,000 years ago. We can confirm that the so-called King's Chamber shaft in the Great Pyramid pointed directly at the pole star of its era, Thuban. This technology transforms enigmatic stones into precise astronomical sighting devices. It allows us to distinguish between a general reverence for the sun and a specific dedication to the sunrise on the morning of the summer solstice. The software provides the hard data, the celestial clock that was frozen in stone. Yet this powerful tool also introduces a profound new challenge. Just because a line points to a star, does that mean the builders intended it? The software can show us the sky, but it cannot tell us the meaning those people saw in it. We are left to interpret their intentions across a vast gulf of time, culture, and lost belief. Our modern scientific lens can sometimes distort the past more than it clarifies it. When we discover a perfect solstice alignment, our first instinct is to label the structure an observatory, a calendar in stone. But this imposes our own fragmented worldview onto a culture that likely saw no separation between science, spirituality, and mythology. For the people who built these monuments, a sunrise piercing a temple doorway was not merely an astronomical event to be logged. It was a moment of divine communion, the symbolic rebirth of a sun god, or the annual reaffirmation of a king's sacred covenant with the cosmos. The alignment was the mechanism for a spiritual experience, not the end goal itself. We can measure the angle of a shaft to a fraction of a degree, but we cannot measure the awe and reverence that filled the chamber when the light arrived. This is the core of the challenge. We are trying to read a sacred text written in a language where every symbol holds multiple layers of meaning, and we have lost the dictionary. A corridor aligned with the star Sirius might have been a practical marker for the Nile's flooding, but it was simultaneously a pathway for the soul of the pharaoh to join the goddess Isis in the afterlife. The physical and the metaphysical were one and the same. The true lost science, then, may not be the geometric technique for finding true north. It is the holistic, symbolic mindset that could seamlessly weave the motion of a planet, the growth of a crop, the authority of a ruler, and the journey of a soul into a single, coherent story written across the landscape. Our precision in measurement gives us a false confidence that we understand their purpose, when in reality, we are only reading the footnotes of a text whose main chapters have long since turned to dust. The detective's work is only just beginning, and the map of this lost science is still being drawn. Vast, impenetrable regions like the Amazon rainforest, the Sahara Desert, and the remote highlands of Central Asia hold secrets we have only begun to glimpse from the air. In the Amazon, LIDAR is already revealing the ghosts of colossal earthworks and geometrically precise road networks beneath the canopy, suggesting entire civilizations whose celestial beliefs are a complete mystery to us. The next great discovery, a city aligned to an unknown star, could be waiting in the next day to set, but the search is not confined to land. The world's coastlines, which were dry land thousands of years ago when sea levels were lower, are a new frontier. Off the coast of Japan, the enigmatic Yonaguni Monument lies submerged in deep water. Its massive, terraced blocks and sharp angles look for all the world like a sunken pyramid or plaza, a structure that, if proven artificial, could rewrite the timeline of Pacific civilization and its relationship with the sky. Proving whether it is a natural geological formation or a deliberately aligned megalithic site is the kind of challenge that underwater archaeology is now rising to meet. Meanwhile, the very tools we use to probe the cosmos are being turned on the monuments themselves. Muon tomography, a revolutionary technique, uses cosmic rays from deep space to see through solid stone. By tracking how these subatomic particles pass through the Great Pyramid, scientists are creating a kind of X-ray vision, revealing hidden voids and chambers that have been sealed for millennia. Are there new, unknown shafts pointing to forgotten stars? Do these secret rooms hold the key to the pyramid's ultimate purpose? The stones are beginning to give up their final secrets. And with the sheer volume of data we now have from thousands of sites, a new kind of pattern recognition is needed. This is where artificial intelligence enters the story. An AI can analyze the orientation of every known temple, tomb, and stone circle across continents, searching for subtle, human-overlooked correlations. It might detect that a specific alignment to the star Arcturus appears in cultures separated by oceans, or that a certain Mathematical Chinese letter is used in monuments built 1,000 years apart. This global analysis could finally reveal the underlying grammar of this ancient celestial language. The story of monumental alignment is not a puzzle we have solved. It is a living investigation, a grand detective story where every new technology, from deep-sea robots to cosmic ray detectors, offers a fresh clue. So what does this grand, unfolding mystery, this conversation with the ancients, ultimately mean for us in the modern world? Our journey through these silent stones reveals a humanity deeply conversant with the heavens. We are left not with ruins, but with the pages of a forgotten library, its texts written in the language of geometry and light. These monuments tell a story of people who saw themselves as threads woven into a vast, orderly cosmos, and who went to incredible lengths to build that cosmic order into the very bedrock of their world. While we may never fully recover every nuance of their celestial logic, the pursuit itself transforms our understanding of human ingenuity. It speaks to a timeless desire to find our place in the grand scheme, to build bridges of stone toward the divine. So the next time you stand before an ancient monolith or simply look up at a star-filled sky, remember you are witnessing the same celestial dance that once inspired our ancestors to raise their wonders. The stones have not given up all their secrets. The mystery endures, a silent invitation to keep looking, to keep questioning, and to keep listening for the echoes of that lost conversation between earth and sky.